Welcome to The Explainer. So, today, we're exploring a completely fascinating intersection between the tangible, dirty hands world we live in and the highly abstract digital frontier. We're going to look at two highly specialized systems that, honestly, on the surface couldn't seem more different. Yet, structurally, they share the exact same mission: securing a perimeter.
I mean, it sounds like the setup to a weird joke, doesn't it? What does the suburban backyard have in common with the decentralized blockchain network? Well, the answer lies in how they interact with the outside world. Think about it. Both are completely isolated environments that desperately need a highly secure, reliable boundary to protect what's inside, while simultaneously allowing for safe interaction with what's outside.
All right, let's really dive into this. On one side, you've got the physical chain-link fence. You know the one. A total staple of backyards, industrial parks, and security perimeters basically everywhere, made of woven galvanized steel. On the other side, we have Chainlink, the digital decentralized Oracle network that secures smart contracts on blockchains. Throughout this explainer, we're going to unpack the history, the mechanics, and the economics of both to see exactly how the concept of a Chainlink secures our physical and digital limits.
Part 1. Securing the Physical Perimeter, a History of Woven Wire. So that classic fence you see around the local tennis courts or power stations, it didn't just appear out of nowhere. It actually has a remarkably innovative industrial history. In fact, the foundation of the physical chain-link fence comes straight from the textile industry. Back in 1844, a guy named Charles Barnard, who lived in Norwich, England, which was a huge cloth manufacturing town at the time, invented a machine to produce chain-link netting based on cloth weaving machines. Fast forward to the US in the 1890s, and the American Chainlink Fence Company, driven by a patent from Guy Maffera, began manufacturing continuous wire fabric. But it was actually his brother, Frank J. Maffera, in 1930, who patented the method that finally eliminated those ragged, super dangerous edges at the top of the fence. This was the brilliant innovation that made the chain-link fence safe and practical for your everyday residential use.
Today, that physical security basically boils down to two main specifications. And what's really interesting here is the difference in the actual materials. For residential backyards, you're typically looking at an 11.5 gauge wire mesh supported by 1 3/8-inch line posts. It's perfect for marking property lines or, keeping the dog in the yard. But if you're securing a serious industrial site, you step up to the commercial spec. That means a much thicker 9-gauge wire mesh with heavy-duty 2 3/8-inch posts. The thickness of that steel gauge is literally the barrier standing between your valuable assets and an intruder.
Section 2. Securing the Digital Perimeter, the Oracle Problem. Now, just like a physical property relies on the thickness of its steel, digital properties, specifically blockchains, rely on the thickness of their cryptographic security. But blockchains have this massive vulnerability. It's known as the Oracle problem. See, they are deliberately isolated from external systems so they can remain tamper-resistant and highly secure. But this isolation means they literally cannot inherently fetch real-world data. They don't know the outcome of a sports match or the price of a stock. If a smart contract uses just a single centralized source to get that data, well, it creates a massive single point of failure. If that one source gets hacked or goes offline, the whole smart contract fails. And this is exactly where the digital Chainlink comes in. It's a decentralized blockchain Oracle network that securely connects these isolated blockchains to real-world data, existing APIs, and traditional bank systems, all without sacrificing that core security.
And think about how a physical fence can be customized with gates to let specific things through, right? Well, the digital Chainlink uses something called the Cross-Chain Interoperability Protocol, or CCIP. CCIP allows 3 distinct things to safely pass through its digital perimeter. First, arbitrary messaging, which is basically just data or instructions. Second, token transfers, which is the movement of digital assets. And third, programmable token transfers. This is the real game changer, allowing users to simultaneously send tokens and the instructions on exactly what to do with those tokens the moment they arrive.
Section 3. Installation and Maintenance. Mechanics. Digging holes and staking tokens. So how do we actually set these boundaries up? Whether you're wrangling galvanized steel or cryptographic tokens, creating a secure boundary requires a highly specific set of installation mechanics. Let's start with the literal heavy lifting of physical installation. According to the Hoover Fence Manual, precision is absolutely key here. First, you've got to dig your holes. For residential fences, this generally means a 6-inch diameter hole dug 30 inches deep, or below your local frost line so the freezing ground doesn't heave the post upward in the winter. Next, you fill that hole with wet concrete and literally stick the post right into the center, plumbing it with a level. Finally, after that concrete cures, you weave and mechanically stretch the galvanized wire fabric across the posts, tensioning it up nice and tight so it doesn't sag. Look, it's hard.
Physical labor, for sure. But as this totally fantastic customer review from the Hoover Fence Manual points out, it is manageable if you've got the right instructions. This customer actually wrote, "My son-in-law and daughter said they would be glad to install it for me." Then I find out he has no idea of how to do it, but he does know how to operate a post hole digger. I love that. Sometimes a little brute force and a good instruction manual are really all you need for physical security.
All right, let's shift over to the digital realm and see how this builds out. The installation of digital security obviously doesn't require a post-hole digger, but it does require committing resources. In the Chainlink network, security is generated through something called staking. In the v0.2 update, participants lock up or stake their linked tokens in smart contracts. Through the Chainlink rewards program, these stakers earn non-transferable points called cubes based on what they've staked. They then allocate these cubes to different projects within the ecosystem, and finally, they can claim unlocked tokens as a reward for basically providing this whole security foundation.
Section 4. The economics of security, costs and rewards.
Setting up boundaries is never free, right? The economics of securing a perimeter, whether you're paying for physical labor and steel or locking up digital capital, tell us a lot about how we actually value safety and reliability. For a physical Chainlink fence, the cost is heavily dictated by geography and local labor rates. If we look at data from Urjon's installation records, a standard residential fence down in Georgia costs roughly $30 per linear foot installed. Move up to Pennsylvania, and bam, it jumps to $45. Down in Maryland, it peaks at around $57 per foot. The materials? They're largely the same, but the local market for the physical labor to dig those holes and stretch that wire drastically changes your bottom line.
And what if you want that thicker 9-gauge commercial spec security we talked about earlier? Well, you'd better prepare your budget. A typical residential installation averages about $41 a foot globally, but commercial spec leaps to $75 a foot. That is an 85% price jump just to upgrade the thickness of your steel and the diameter of your posts.
And that perfectly illustrates the raw cost of robust security. Shifting back over to the digital Chainlink, security is sustained through crypto-economic incentives rather than hourly labor rates. In the staking v.2 protocol, assuming the community pool is filled, participants receive a base floor reward rate of 4.5% per year for locking up their tokens and helping secure the network. This yield acts as the economic engine that literally motivates people to maintain the digital perimeter.
But hey, it's not just free rewards. Digital security has incredibly strict quality control mechanisms to ensure the Oracle network doesn't provide faulty data. Because remember, garbage in means garbage out. The system utilizes a slashing mechanism. If a node operator serving a critical feed goes down for more than 3 hours, community stakers can raise an alert. A valid alert actually rewards the alerter with 7,000 link tokens. Meanwhile, the underperforming node is strictly penalized, or slashed, losing 700 of their staked link tokens. It's this highly automated economic system of checks and balances that ensures our digital fence absolutely never sags.
Section 5. The Ultimate Connections, Linking Worlds.
So, stepping back to look at the big picture, we've explored the history, the installation, and the economics. But looking at the grand architecture of what these systems actually achieve in our modern world is mind-blowing. A woven steel wire fence might protect a family dog, a local tennis court, or a critical municipal power grid. It creates a physical limit that deters trespassers on site. The digital Chainlink network? It does the exact same thing, but for the entire global financial system. By solving the Oracle problem and enabling cross-chain interoperability, Chainlink secures over $27 trillion in transaction value. It is literally the invisible digital perimeter being adopted by massive financial titans, like SWIFT, the global messaging network for 11,500 institutions, and the DTCC, which processes quadrillions in securities.
So, here is the ultimate takeaway. Whether you're out there twisting 9-gauge galvanized steel around a 30-inch concrete footing, or writing a smart contract that stakes digital tokens to verify off-chain data, you are fundamentally doing the exact same human task. You are building trust through verifiable boundaries. As our tokenized digital assets become just as critical as our physical real estate, I want you to ask yourself, as these worlds intertwine, what does the future of security really look like? And just how strong are the links in the chains protecting your world? Thank you so much for exploring this with me today, and as always, keep learning.